Okay, it's 11 o'clock, so let's make a start. Good morning. Thank you for taking the time to join me for today's webinar. My name is Mary O'Brien and I'm one of the consultants in the FME team here at One Spatial. And today we're going to look at using FME for land management. So here's what I'm planning to cover. We'll start with an introduction to ourselves here at One Spatial and then to FME, so explaining what FME is, what the different products are. So for any of you that are new to FME and you've joined today to understand if FME might be useful for you. And then we're going to look at some examples using FME, so drawing on some projects where we've worked with customers in the land management sector. If you have any questions as we go through it, please post them in the chat window and then we'll look at them at the end. And we should be about 30 minutes or so. Okay, so just to start with, a little background on ourselves here at One Spatial. We're a spatial solutions provider and we have offices across the globe with our headquarters here in the UK in Cambridge. And we work with customers within a number of key industry sectors, so utilities, transport and engineering, and all levels of government. And in particular, we work with a number of national mapping agencies and others within the land management arena. We have a number of technology partners that we work with, and the one we're interested in here today is our partnership with Safe Software, and they're the producers of the FME products. So Safe Software themselves, they're based in Vancouver, in Canada, and they have a network of partners across the globe, and really a very active user community. And here at One Spatial, we're a platinum partner Safe Software, and we've been working with and reselling FME since about 1999, so for quite some time. And we provide support for all of the FME products. We have a team of skilled FME people, so we can help you really with any FME related questions or problems you might have. Some of the services we provide, we provide training, we provide support through our support portal and consultancy services on the FME product set. So if you're interested or if you're having any problems in getting started with FME or with getting the most from your FME workflows, then please do get in touch with us. It's fme@onespatial.com and I'm pretty sure that we can help you. So for those of you that are new to it, we'll start with a very brief introduction to FME. What is it? Well, it's a really powerful tool for managing and manipulating your data. FME stands for Feature Manipulation Engine, and that's really the best way to think about it. It's a processing engine for data that lets you, convert data between hundreds of different formats. So if your data is stored in databases or flat files, it doesn't really matter. FME can help you get your data, from one system to another, from A to B. And it's also a fantastic data transformation tool. So you can do all sorts of different transformations. So, maybe you want to change the structure of your data so that it matches some standard that you need to adhere to. FME can help you with that. Or you want to calculate some values or do some geometric calculations. Maybe you need to, calculate areas or perimeters, so field areas, field boundaries perhaps. Or maybe you need to pull together different data sets from lots of different sources, all in different formats and in different structures. Well, that's all possible with FME. It's bread and butter really, if you like. And there are a number of different products in the FME family that we can use to help us. So first off, we've got FME Desktop. and that gives you FME, an ETL solution on your desktop machine. So this is where we build our data processing workflows, our logic that we can reuse, and they look a little bit like this. So it's got a nice user-friendly interface. There are no coding skills required. If you have them, that can be useful. And then you can build and run some really, really powerful data processing tools through this product. And it's the key component, really. It's the product that we use to define those repeatable, logical workflows that will process our data for us. And that's where our focus will be today. Next up, we have FME Server, and this really allows you to automate those FME workflows, but on an enterprise level. So either by running them on schedules or by using notifications, so on. So you still need FME Desktop to build your workflows, but now instead of a single processing engine on your desktop machine, you can have multiple engines with a server. So you can have many jobs running or processing data, and you simply add more engines to scale your processing power. It's all accessed and managed through a web interface, so everyone in your business can access it and use it just through a web browser. And then you've also got options, for distributed architecture and failover and so on. So it's really giving you an enterprise-friendly configuration for production and business-critical systems. And then the final member of the family is FME Cloud. And this is FME Server, but sitting on the cloud. So it's a hosted FME server solution using Amazon Web Services. So instead of using your own hardware, you get the flexibility of different hardware options through AWS. And you get FME Server with unlimited engines, giving you flexibility in terms of your platform as a service. So we're going to jump right in and start by looking at some simple but fundamental capability in FME. So we're interested in land-based data sets today. So the spatial element is really important. So we're going to look at how FME can help us just easily add the spatial element to our data. So here I've got a CSV file. It's some recycling centres in Nottingham, and we can see we've got some coordinates in there, eastings and northings, lat long values, but it's a flat file, an Excel file, and really we'd like to create some points for those centres. So let's take a look in FME at how we might do that. So here's my canvas. We simply want to add some data, so I'm going to read the data from my CSV file. Here it is. I'm going to choose the parameters button, which allows me to configure how I want it to be read. So I'm just going to read it in using all the defaults here. We can see that it's splitting it by commas. And then rather than let it read them all in as strings, I'm going to choose that my easting and northings are interpreted as an x coordinate and a y coordinate. And then I'm going to set my coordinate system as British National Grid, so it's 27700, and I'll click OK on that. So that's going off scanning the data set, and it's going to bring in its structure and place it on the canvas here for me to play with. So it's picked up all of the attributes that are in there. Just going to add an inspector or a viewer. I'm going to press play. It's going to read that data in. It's going to interpret the eastings and northings as coordinates and then display it for me in the other application, the data inspector, which is just opening on my other screen at the moment. So here I've got the table view, if you like, for all of the records, and I've got the map view, so it's interpreted those coordinates and created points for me. Great. So let's say I wanted to write it out very simply as a GIS file. Let's go for a map info file. Just choose an output location. I'm just going to go with all the defaults, copy this definition from the reader, so the thing that I added, where I read it from. There we go. And I can see that all of the attributes are being carried across, and importantly the geometry also. So now when I want to, I'm happy, I can simply press play. It's going to read in the CSV file, and it's going to write out a map info tab file, which is now storing the geometry all ready for me to use in my GIS. Okay, so very simple, but kind of a fundamental functionality that we typically want to do. Now on the same theme, but let's say we've got instead some geometries that are sitting in a file. So here we've got some neighbourhood boundaries in a GIS file, and then we've got an Excel file here with information, and our information here is just about some planning applications per neighbourhood. And we want to be able to display this planning information on the map. So we want to perform, a classic join, something I'm sure you're all familiar with, but we'll just look at how we do it in FME. So if I bring across my FME and my workspace, so in FME, here I've got my two inputs, my neighbourhoods, which is a KML file, which is the boundaries, and then my planning applications, which came in from an Excel sheet. And we use transformers in FME to do the jobs for us. So in this case, we want to join the data, so we're using a feature joiner transformer. So I simply pass my neighbourhoods in this case as the left, and my planning applications in as the right. And the left and right reference is to do with SQL joins, so I can choose the kind of join I'm doing, but basically I'm going to join these two data sets where the neighbourhood name matches. So if I simply press play on that, we'll get some neighbourhood polygons, and they'll now have their look at the output. I've got my neighbourhood polygons now with all of their planning applications attached to them. So you can now, do the same thing, write this out to a shapefile or a map info file, generate your thematic maps or whatever it is that you want to do. And there are a number of different ways that we could do this, in fact, in FME. There are multiple transformers that we could use to achieve the same result. So we could do the same thing, similar with the database joiner, but in this case, rather than the Excel file already being read into our process, at this point in the process, we would go off and connect to the Excel file and bring in just the data that was joined. So why might this be important? Well, it could mean that we don't have the overhead of reading in a second data set with all the attribute information. We would just read in what is joined. So that can be a really efficient way of doing this kind of task. Let's say if our data with the attributes sits in a database, for example, and we can use the indexing and searching capability of the database. And actually, if you're interested in planning data, look at the Nottingham Open Data website, So I've gotten some of my sample data from there, but they've got all sorts of local authority data available under an open data license. So it's essentially free. It's refreshed nightly, and it's all powered by FME. So the guys in Nottingham have built some of these FME workspaces, these logical workflows, to pull together the latest data from different sources across the council, and then they publish their output to this website. It's pretty clever. But they're using FME Desktop running on a Windows task scheduler, and that will run the process every night and then refresh the data daily. So it's all very hands-free, all automated, and up-to-date current data available every day. Okay, so our next example, this time we're going to look at Land Registry data. And it's a really important source of information for engineering companies, among others. So when they go out in the field to undertake works, the engineers, first of all need to know, well, who owns the land they need to cross to get access? Who do they need to notify? Maybe what compulsory purchase orders are they going to need, and so on. And secondly, they need to know, well, what infrastructure is beneath them. The country is crisscrossed by high pressure oil and gas pipelines, and actually they're not buried very deep. So, these guys need to know if they're about to dig and hit a pipeline. So there are a bunch of companies providing services around this theme, identifying for particular sites what is in an area. And we've worked with a few that are using FME to do this kind of spatial analysis. So here we're going to look at an example where we worked with Fisher German, and they're using FME to process the land registry data for this kind of purpose. And the Land Registry holds information on the title deeds for every parcel of registered land in England and Wales. So this gives engineers the information they need to notify landowners and occupiers and gain legal access rights which they need to do their work. But when you submit a buffer polygon around a site, you're charged for every polygon that intersects it. So even if your field only touches, if a field only touches your area of interest, it's included. And that can work out quite expensive because we're dealing with hundreds of projects here ongoing at any one time, so it can all soon clock up. However, the Land Registry also publish index polygons for the land parcels. And this dataset is available freely to download under the open data license. It's chopped up into areas, so if you need full coverage, then you're going to have to download all those zip files, extract all the data, and work with it from there. And this is where FME came to the rescue, really. So we could use FME to download the polygons from the website and then identify just the polygons of interest to the project, so you only need to buy the polygons that you need. And then finally, we could use FME to process the returned title deed information also. So this means they were saving time and money, so no longer does somebody have to sit and download the data with every monthly refresh. We've got a repeatable process that we can simply run monthly and then wait for the results to come in. So let's take a look at it in FME. So I'll just zoom in here to start with. So to start with, we're reading in as text the web page where the index polygons are available. So this web page here, where all of the index polygons are listed and available to download. You can see their links here. And then here we do some text manipulation just to parse that HTML file, strip out the bits of information that we need to find the file names. And then we build the URL, the path to the download file. And then at this point, I'm using a test filter to identify just the area that I'm interested in. So in this case, I'm just going to run it for the City of London. Should be quite a small file. That would work for a demo. So here's all the preparation. And then at this point, we're actually hitting the service to go and get that file. So it goes and downloads the file for us, or hits the URL, and we read the GML file directly from the website. So we're pointing FME at the zip file, but it can dig inside and grab the GML and return us that. So it returns us the actual data. And then here we're just manipulating the structure of that data, deciding which attributes we care about and which ones we want to keep. And then we're outputting it here as a shape file, and we're getting one for each area that we've output. And each time, that we need to gather this data, so every time there's a refresh, we simply rerun the process, and it'll go and grab the latest data from the website again. So we're always getting the latest data, and it's always running automatically for us. So it's pretty smart stuff. Okay, so now we have the data, we needed to manipulate it to make it work for us. And again, we could use FME to help us. What we get is just geometry, so we need to join it to the attribute information, and that's just like our earlier simple example where we wanted to join the planning applications to the geometry. We can use those same transformers. And we can see also that the land parcel data has some tiling remnants. And this is a hangover really from many years ago when it was stored in a massive IBM database that needed it to be tiled for storage. But technology's moved on, but because these are legal boundaries, there are rules about altering them. And in fact, the only time you can alter them is when a land parcel is sold. So in the data, we still see the tiling artifacts in parcels that haven't changed hands since that time. And there are, there are also issues like not all parcels have yet been digitized, yet more are overlapping, there's duplication and so on. But the upshot being that we can have real problems using this data in its raw format when we want to do calculations like areas and so on. So we can use FME to manipulate the geometry to provide us with a more useful polygon for what we need. That's kind of a standard problem or common problem, and the standard approach really is to aggregate them and then dissolve them. So we aggregate using the aggregator transformer, so we aggregate or combine them based on the same parcel ID. And that gives us multi-part features, and then we can dissolve the common boundaries, which are the tile lines, and we can use the dissolver transformer for that. And you can see the results here in pink. And in this example, we can see we've got some poorly digitized boundaries actually. So we've got a gap, or in fact it's a spike. So we've done some further manipulation using the spike remover transformer to just smooth that out. And then we end up with the polygons in green here, which are much more like what we were expecting. And there are a bunch of different transformers in FME that you can use to manipulate the geometry in different ways, depending on what's appropriate for your particular data. So I've just listed some here that might be useful to you. Okay, so then it came to processing the title deed information, the attributes. And that was pretty tricky because we found lots of different data scenarios. So we've used lots of tester and test filter transformers to identify the different scenarios, and then we used like an if then else approach to processing. So if my data is in this scenario, then I'm going to do this, otherwise I'm going to do something else or pass it on to the next stage. So to give you some examples, first challenge, well, we needed to split the proprietor value into name and address fields. And from inspecting the data, we found that if it began with a space, then it was a commercial business record. So we can see an example here in purple at the top. So we added a test to check for white space at the start. And then we knew we were in the commercial scenario. So for commercial records, name and addresses were distinguished by 2 white spaces between. So we used an attribute splitter transformer, and this let us split the value into the name and the address elements. And then we used an attribute manager to just rename those to the expected attribute names in the target system. And then if we weren't in the commercial record scenario, so the failures from our test, then we had a residential record. And for residential records, when we examined them, it seemed that the name and address are differentiated by 4 white spaces between. So we could again use the attribute splitter, but with 4 spaces to separate out the name and address elements. And again, the attribute manager was used to rename those to the attributes that the target system required. So we now had name and address separated out for different data scenarios. Next, we needed to do a little more work on the address element. So Fisher-German needed the output to be split into multiple address fields. That's how their systems needed it, so we needed to add more logic to our FME workflow to handle this. Again, we used the attribute splitter to split the address, and this time it was where commas occurred. So we get 3 address elements identified. And again, we used the attribute manager to rename these to match what the output system wanted. So address 1, address 2, and town. However, some data in the 3rd address element, town, also contained a postcode. So not just the town. And this was a problem because we wanted that to go in another field, a separate field called postcode. So to tackle this, we used a string searcher transformer and some regex to look for the existence of a postcode string of letters and digits in the town field. And if we found one, then we split it to put the first part in the town field and the second part in the postcode field. And that solved it. And yeah, there were lots of different data scenarios, different data challenges to deal with, but they were all on this similar theme of extracting strings of information. But essentially, we managed to process the data from its original structure into a structure that fit what Fisher-German needed for their downstream processing. And as we built this logic into an FME workspace, then we can very easily reuse it with each new refresh of Land Registry data. So before using FME, to process the Land Registry data to get it to fit what Fisher-German needed involved lots of manual processing. It took several days to complete with 2 or even 3 people working on it. Now with FME, they have a new streamlined process that automatically reads the title deed data and outputs a new, better structure just as they need it. And you can process any number of files at a time. So to give you some idea, for 6 projects, that's about 24,000 Land Registry records. That processed an FME in 30 seconds, whereas previously it took about 6 days to manually process those files. So, an amazing time saving. Staff can now, are now freed up, they can go work on more interesting analysis tasks, but also they no longer need to pay extra to get their data restructured from the Land Registry. They can do it all in-house with FME, so it's really a double cost saving for them. Okay, another example where a number of customers are using FME is for processing data related to rural farm payments. Farmers can apply for funding under a number of different schemes. For example, the Basic Payment Scheme provides grants and payments to farmers based on the land that they have in use. And depending on what crops, for example, they've grown, then they may be eligible to claim for payments from the EU. And a number of agencies process these claims. As you can imagine, there's a lot of spatial data processing, in particular processing of land boundaries involved. So we work in particular with the Rural Payments Agency to support them in their work to assess and calculate payments. And FME is a fundamental component of their process. But similar agencies in other geographic areas like Scottish Government, Welsh Government and DERA in Northern Ireland, they're all using FME also to assist them in managing this task. What kinds of tasks are we talking about? Well, for example, FME is used to identify which areas of land are eligible for payments, and calculate their area so that payments can be calculated. And when they need to assess claims remotely, so from the office, FME can be used to compare the land parcels submitted this year against previous submissions. And additional data to help assessors in their job, like aerial imagery, satellite data, base mapping, that can all be processed by FME also. Another key area is performing farm inspections. So this is where inspectors go out on site and assess the claim of the farmer. And FME is key here in providing the relevant farm data to the inspector to enable them to do their inspection. So an inspection pack of data. And then FME is also instrumental in managing the return information, so the results from that inspection, so that the database can be updated. And of course, FME's format capability, that's key in ensuring that the claim calculations that have been done are submitted to the finance system that handles the payment processing. So these are just some of the areas where FME is currently being put to use in processing data for rural payments. Next up, something I touched on in the last example, processing raster data. So raster data is, of course, really important for the land management sector. And FME supports many different raster formats, both reading and writing to those raster formats. So a good place to go is to check out the SAFE website, safe.com/formats, for a listing of all the supported formats, including rasters, and you can check if your format of interest is supported. But all the major raster formats that we'd expect are supported. So you've got imagery formats like TIFFs and ECWs, continuous data like ASCII grids and DEMs, and then some of the newer scientific formats like Sentinel, satellite data, and Planet. FME has support for them all. And there are a whole family of transformers that act on raster data also. So for example, the raster mosaicer, that lets you combine or stitch images together. You've got the raster tiler, which lets you split data up into tiles based on either size or quantity. And a really useful one to know about, because often you need to resample rasters to work with them together. So the raster resampler transformer lets you do just that. Here's another example. So you might need to generate either true color or false color imagery from your satellite data by combining data from the different bands. And again, there are a bunch of transformers in FME to do that, like the raster band combiner. And in fact, there's an example demo on the Safe Knowledge Center that you can use, borrow, or reuse to get you started if interested, on the links at the bottom of the screen. Here's another example where we were helping a customer with their raster data, so taking their supplied TIFF files and outputting them in a different format, so ECW, but with a different, bigger extent. And this was for performance reasons in their downstream process. So we've got a very simple looking workflow here, but it's a bit deceptive because there's actually a lot going on. We're using FME's dynamic mode to read in all the data files through a single feature type here, and then we process them and output them as ECWs based on their tile name. And that replaces this workflow, which had literally hundreds of readers, one for each input file, for each input TIFF. And while it worked and produced the correct output, it took a very long time to run. And it was, as you can imagine, very difficult to manage. So we've streamlined the process so that it runs more efficiently, but it's also, a heck of a lot easier to maintain. We've got just this one flow line to maintain. So, if you're using FME and you're concerned that maybe your data processing is taking too long, or you think there may be a better way of doing it, then get in touch with us. This is where maybe we can use our expertise and experience to help you optimize your workflows like we did for this customer. And on that theme, we come to our final example, where we worked with Ordnance Survey to help them assess and optimize really an existing FME workspace that they had for processing some of their production data. And OS undertook a major project some time back to consolidate their data products into a single holding. That's termed the GDMS. And we're talking about massive implementation that enabled them to maintain their data seamlessly and also build and develop new products. And there are a whole host of different best-of-breed COTS products involved. FME is just one component of it. So in our example, FME was used as a test harness to test and ensure that while the process changed, the actual data being produced doesn't. And of course, we needed also to optimize the workspace and take advantage of new features in FME, since the original workspace, which had been written in FME 2009. So what did we do? What were the key optimizations? Well, firstly, like in the previous example, we could make use of dynamic schema functionality in FME. So we reduced the number of input layers from 96 to 1, so making it a lot easier to maintain. And there was a whole bunch of duplication then, with the same logic being applied for each layer of data. And using dynamic schema mode and having just that one input layer meant we could automatically reduce the transformer duplication also. So that was a bonus. And of course, the less transformers there are, in general terms, the more performant the workspace. And where logic does need to be repeatedly used, we made use of custom transformers. So custom transformers are simply bundles of transformers, or you can think of it as modules of code. And they can be reused throughout the workspace wherever they're needed. And again, it makes the whole workspace easier to understand and manage. You can identify them because they're typically green or cyan in colour, which distinguishes them from the blue standard product transformers. So if you're interested, a little while ago, we did a webinar on custom transformers and how to create them and how to use them. So you can check that out on our website. Another improvement, a top tip really, get familiar with the schema mapper transformer. It's a fantastic transformer that allows you to store the schema or the structure configuration in an external file, like an Excel file, and then apply it to your data within FME. And that meant we could replace, about 211 attribute renamer transformers with one single schema mapper transformer. And then the whole process became a lot more performant and a lot easier to manage. And because the configuration is stored in Excel, it also meant anyone could alter the process simply by editing the config file in Excel. They didn't need to be an FME expert or have any interaction with FME to do it. And finally, but a really important point, we added lots of documentation to the workspace to explain clearly the process, but also the reasoning for the logic that was applied. So this is extremely important, and just can't stress this enough. You might think that your logic is obvious, it makes sense now when you write it, but believe me, when you come back to it in 6 months or years later, as was the case here, then you'll be glad that you added some annotation just in plain English to explain it. So here's a quick before and after of the workspace. You can see it's a lot simpler by comparison. It's still complex, but a vast improvement. And it was a lot more performant too. So it now runs in less than 50 minutes, has a lot fewer transformers to maintain, and even the length of time it takes to simply open it to maintain it has dropped significantly. So just some final thoughts really. Hopefully we've shown that FME can be a really useful tool for managing both your spatial and non-spatial data sets. Lots of you in the land management sector are already aware of FME, and many of you have licenses and are using it already, which is great. So perhaps from today's session we've highlighted some other uses that you might not have thought of that are of interest. So you might now have some new uses hopefully for FME to help maximise your investment in it. So if we've sparked your imagination and you'd like to discuss your ideas further, please do get in touch. It's fme@onespatial.com, or you can get in touch directly. You've got my contact details there. So that's it from me for today. I've got some links here to references that you might find useful, and if you download the webinar afterwards, you'll also get them. And just a final point, which is that the FME World Tour for next year, for 2019, the dates are now set and the call for presentations is open. So if you've been working with FME and you'd like to present that back to the user groups, to the user community, and let us know. We've got 4 events happening: June the 5th in London, June the 7th in Cardiff, June the 10th in Leeds, and June the 12th in Edinburgh. So get those dates in your diary, and certainly it's a really useful way of finding out more about FME and also finding out what others are doing with it. And as I said, if you're interested in presenting, then please do let us know. Just contact us, fme@onespatial.com. Okay, so that's it from me. If we have any questions in the chat window, I'll go take a look.